What if your consciousness could be given a score? What if it could be calculated with equations and expressed as a number? Giulio Tononi, a neuroscientist and psychiatrist, attempted exactly that. His integrated information theory, proposed around 2004 and revised over the years, claims that consciousness can be measured as a numerical value called phi. IIT was updated and formalized as IIT 4.0 in 2023 and continues to evolve. But here's what I keep wondering. Can the quality of consciousness truly be measured as a quantity? When you see red, can an equation capture the redness you feel? Today, let's explore the revolution and controversy integrated information theory has sparked. What this attempt to mathematize consciousness reveals and what it overlooks. By the end of this video, science's approach to the mystery of consciousness will raise new questions within you. Chapter 1. Integration as the key. Once thought to be 100 billion, the latest research suggests around 86 billion neurons. But consciousness isn't born from numbers. The key is integration. So what does integration mean? According to Tononi's theory, consciousness is determined by the degree to which different parts of the brain integrate information. Picture this. When you watch a sunset, your visual cortex processes color, memory regions recall past sunsets, and emotional centers feel beauty. All of this integrates into a single experience, watching a sunset. This is a remarkable insight. Consciousness doesn't arise from a collection of brain parts, but from their connections. Tononi represented this degree of integration as a value called phi. While IIT expresses integration as phi, calculating phi precisely in actual brains is computationally challenging. Currently, verification attempts use approximations and proxy indicators. And here's where a crucial question emerges. If this theory is correct, we may be able to measure consciousness for the first time. Perhaps we could determine whether patients in vegetative states have consciousness, or whether AI possesses it. Yet theories answer one question while birthing new mysteries. Does a high numerical value truly mean consciousness exists? Or are we overlooking something essential? This is the crux scientists continue debating. A large-scale validation experiment published in 2024 supported parts of the theory, but also falsified certain predictions. The matter remains unresolved. But here's what makes this truly revolutionary: its implications. Chapter 2. Does everything have consciousness? Integrated information theory leads us to an unexpected conclusion. If consciousness emerges from information integration, it's not exclusive to brains. What does this mean? As a mathematical consequence of IIT, consciousness exists on a spectrum. Human brains have the highest integration, but dogs, insects, and theoretically even simple circuits or microscopic material systems could have non-zero values. This resurrects an ancient philosophical stance called panpsychism within modern science. Tononi himself has acknowledged this implication from the beginning. Consciousness doesn't reside in brains. It's a universal property that emerges wherever information is integrated. As the theory evolved and this panpsychist implication, consciousness is everywhere, became clearer, philosophy and science erupted in turmoil. Is consciousness a fundamental property of matter? Do microscopic systems have consciousness? This transcends scientific theory. It's a metaphysical claim. If true, our view of the cosmos changes fundamentally. Consciousness would be a basic property woven into the universe, like gravity or electromagnetism. But critics raise piercing questions. Does high integration truly mean consciousness exists? Philosopher David Chalmers has raised the hard problem of consciousness since the 1990s. IIT may explain the structure of consciousness, but it doesn't explain why that structure produces feeling. This is consciousness's greatest mystery, the hard problem. Why do physical processes generate subjective experience? Why is there something it is like to be? Consider this for a moment. If a highly integrated AI system has high phi, does it possess consciousness? From IIT's perspective, whether future AI has consciousness depends on its architecture. Being smart doesn't automatically mean conscious, a contentious debate. Furthermore, in 2023, over 100 scientists published an open letter criticizing this theory as pseudoscience, igniting fierce controversy that divided the field. Tononi's theory is a groundbreaking attempt to mathematize consciousness science. Yet the deepest mystery, the mystery of subjectivity, remains. What IIT teaches us is both the limits and possibilities of science. So how will this theory shape our future? Chapter 3. Measuring the Future of Consciousness. The most vital application of IIT lies in medical settings. Do patients in vegetative states retain consciousness? This is among the most difficult questions physicians face. Previous brain scan studies found traces of consciousness in roughly 15% of patients. And the latest measurement methods applying IIT, such as PCI, Perturbational Complexity Index, are beginning to determine consciousness presence with even higher precision. These indicators, influenced by frameworks like IIT, are complexity metrics advancing research to improve estimates of conscious states. In one study, some patients diagnosed as vegetative may actually retain consciousness. They cannot move, but they may feel, hear, and understand. But the larger question is directed at AI. If AI eventually achieves high integration, how should we treat it? Is it ethically permissible to turn off a conscious being? IIT has transformed what were once philosophical thought experiments into actual technological and ethical challenges. We are gaining criteria to measure consciousness, but we also inherit the responsibility to use those criteria. And here's where the deepest question surfaces. If consciousness is measurable, does that mean it's more material than we thought? Or does measurability diminish none of consciousness's mystery? In his 1974 paper, philosopher Thomas Nagel asked, "What is it like to be a bat?" sharply illuminating the problem of subjectivity. IIT might calculate a bat's integration, but can it truly capture the subjective experience of being a bat, the feel of batness? This question has no answer yet. But what IIT teaches us is that consciousness isn't magic. It's part of nature. Complex, measurable, yet still mysterious, part of nature. IIT may be the dawn of consciousness science. Or it may be the gateway to deeper truths we don't yet understand. Let's organize what this exploration has revealed. Chapter 4. The Endless Quest. Today, we've explored integrated information theory deeply. What this attempt to mathematize consciousness has revealed, and what questions it leaves behind. Let's summarize the endless quest emerging from today's journey. First, according to IIT, consciousness is determined by how much different brain parts integrate information. Represented by phi, it theoretically makes consciousness level measurable. This is a groundbreaking attempt to treat consciousness scientifically for the first time. Second, the theory's astonishing implication is that consciousness may exist not only in brains, but in any system that integrates information. This is called panpsychism, viewing consciousness as a fundamental property of the universe. If true, our cosmic worldview changes fundamentally. Third, yet the deepest mystery, why physical processes generate subjective experience, remains unresolved. Integration may measure consciousness's structure, but whether it captures feeling itself is unsettled. Between what we can measure and what we understand lies a vast chasm. These three insights show that consciousness science has entered a new phase. We're beginning to quantify consciousness. Yet simultaneously, the essence of consciousness, the essence of what it is like, remains science's greatest challenge. IIT left a profound impression on me. Both the courage to grasp consciousness mathematically and the new questions that attempt births. The more science advances, the deeper the mystery becomes. This, I believe, is the essence of intellectual inquiry. What this theory teaches is that consciousness isn't magic. But not being magic doesn't mean it's not mysterious. Rather, being measurable makes its complexity and beauty stand out even more. Finally, I want to ask you, when AI achieves high integration, will we be prepared to treat it as a conscious being? And if consciousness is measurable, can your own consciousness, this I you feel right now, truly be reduced to mere numbers? These questions have no answers yet, but continuing to ask propels us forward. IIT is only the beginning of our journey into consciousness, the final frontier. After watching this video, when you return to daily life, become a little more aware of the feeling you're experiencing now. The moment when sight, sound, thought, and emotion integrate into one experience. That integration is your consciousness. And ask yourself, can this sense of I truly be measured in numbers? That question may lead you to new insights. Share your insights in the comments. Your questions are the force that drives this channel forward. Thank you for joining me on this intellectual journey to the very end. The mystery of consciousness is science's final frontier. This channel continues exploring such profound themes. If you wish to continue this journey, subscribe and turn on notifications. Next time, I have questions prepared that will shake your worldview. Until then,